Today we're going to continue working with right triangles and do a little more right triangle trig. But before we get started, I'd like you guys to give this warm-up a try. This should help us get ready for our Georgia milestone. All these questions here reference exponential functions. So take a look at these, see what you can do with these. You can talk to each other, and please hit pause on the recording until you're ready to check your answers. Okay, now that you're back with us, let's take a look at the answers to these. Number 1, which could be the graph of y equals negative 2 to the x? Well, the negative out in front changes the y's all to the opposite, so it goes from being the parent function, which is this one, and reflects it over the x-axis, so the correct answer is G. Number 2, which equation models exponential decay? Now remember, in growth, our multiplier is greater than 1. In decay, our multiplier is between 0 and 1. So if we look at our choices here, only C has a multiplier that is less than 1. Number 3, which ordered pair lies on the graph? Well, all you had to do was plug in your x and see which one gave you the correct y, which in this case is choice H. Okay, if you'll pull out your homework, the next thing we're going to do is look at the homework, and just take a minute and you can hit pause on the recording once again and check all of your answers, make sure you understand, and help each other out if you don't. So when you're done checking your answers, go ahead and press play again. Okay, so yesterday we learned about the ratios for a right triangle. So here we have a right triangle, triangle A, B, C, and when we name a triangle, the side across from vertex A, which we name with a capital letter, is little a, the side across from vertex B is lowercase b, and the side across from vertex C is lowercase c. So here's our right triangle. Now, this symbol for theta, once again, this is just like saying this is we don't know, a variable almost. Theta is what we use in angle measurement. So once again, theta is our measure here. So if we look at this, if this is theta, well then angle B would have to be 90 minus that, because the three angles of a triangle must add up to 180. And we talked about the triangle sum theorem in the last unit. So let's see if we can come up with these ratios given this information. Sine of A. Now remember, sine is the opposite over the hypotenuse. So with respect to A, lowercase a is the opposite, and the hypotenuse is C. All right, let's look at cosine of A. With respect to angle A, the adjacent side is side B. The adjacent over the hypotenuse is cosine, so over C. Now the next two are referencing this angle here, angle B. So with respect to angle B, to do the cosine, cosine is adjacent over hypotenuse. So with respect to angle B, A is the adjacent side and C is the hypotenuse. Sine of angle B. So with respect to angle B, B is the opposite and C is the hypotenuse. Now look at this. We have A over C, A over C. So these two, sine of A and cosine of B, are equivalent. And we could prove that using substitution. They are equivalent. Now let's look at this. Cosine of A and sine of B. They are also equivalent. The sine of any angle is the same as the cosine of its complement. See, if this is theta, this is 90 minus theta. So the sine of any angle is equal to the cosine of its complement. And vice versa. The cosine of any angle is equivalent to the sine of its complement. Okay, so sine of 10 is equal to cosine of, what is the complement of 10? 80. cosine of 25 is equal to sine of, what is the complement of 25? 65. Okay? And so when we look at our trig ratios, those are equivalent statements. And you could even test it. Pull out your calculator. Make sure your calculator is in degree mode before we do this. Make sure it's in degree mode. But if you punched in sine of 10, you get 0.17. Is that equal to cosine of 80? Well, this is approximate, so we get 0.17. So when we use our calculators, make sure they're in degree mode because we're entering these in degrees. And so we see that we get the exact same thing. You could test it here and see they're equivalent. Okay, let's tie a couple things together real quick. Before our quiz, we did 30, 60, 90, 45, 45, 90. Now we're looking at sine, cosine, tangent. 30, 60, 90, we know those ratios. X, x root 3, 2x. So we could call this 1 times root 3, and 2. It always reduces to this ratio. So sine of 30, SOHCAHTOA, opposite over hypotenuse. So sine of 30 is 1, which is the opposite, over 2, which is the hypotenuse. 1/2. And this is one you'll end up memorizing pretty soon. We could do all of them. What is cosine of 30? Well, cosine of 30 is adjacent over hypotenuse. Square root of 3 over 2. So let's look at the complements. What is sine of 60? Because that is the complement. Sine of 60 is opposite over hypotenuse. Oh, look at there. The exact same thing. All right, with our 45, 45, 90, if we did cosine of 45, it's adjacent over, and what is the length of the hypotenuse if this is 1 and 1? It's got to be the square root of 2. So cosine of 45 is adjacent, which is 1, over hypotenuse. Now we wouldn't leave a radical in the denominator, so we'd have to rationalize. Still have to follow our rules for radicals. So we'd say that cosine of 45 is square root 2 over 2. And sine of 45 is the exact same ratio. If we did opposite over adjacent, we still get 1 over the square root of 2. So this is also square root of 2 over 2. Do you see how these are complements? And they're equivalent. Okay. Today we're also going to talk about solving using right triangle trig. So here we have a triangle, A, B, C, and of course side A is across from angle A, side B is across from angle B, and side C, we're actually given, is across from angle C. So how could we take this information and solve for things that are missing? Like, what if I ask you to find A? What if I ask you to find B? How could we do that? So what we do is we look at what we're given. We're given this, and we're given this. So with respect to this angle, this side A is the opposite, this side B is the adjacent, this side C is the hypotenuse. So if I looked at what they gave me and what I want, they gave me the 25-degree angle. This is opposite, so I'm going to do this one in blue. But they also gave me the hypotenuse. Which trig ratio is a ratio of opposite and hypotenuse? That is sine. So we could set this up. Sine of 25 degrees is equal to the opposite side, A, over the hypotenuse, 10. And simply to solve this, we just multiply both sides by 10. Now, on a standardized test, this might be your answer. 10 times sine of 25. But we want to go ahead and convert that to a decimal. And the way you would do that, once again, make sure your calculator is on degree mode. So if you hit the mode button, make sure degree is highlighted. If it's not in degree mode, you won't get the same answers I do. So if it's standardized test, this could be your answer, but we're looking for a link. So let's approximate this, and if you punch in 10 times sine of 25 on the calculator, you get 4.23. Now our second example, I'm going to do it in red. We're going to find B this time. So we want B, and then we always go with what they gave us. So they gave us H. We want the adjacent. They gave us the hypotenuse. Adjacent hypotenuse is cosine. So now we're dealing with cosine. Cosine of 25 is equal to the adjacent side, which is side B, over the hypotenuse, which is 10. So once again, to solve, we simply multiply both sides by 10. And so on a standardized test, this is the exact answer. But when we're working in reality, we'd want the decimal approximation for that. So once you punch in 10 times sine of 25, we get 9.06 is the approximate length of B. So now we've solved for the two missing sides. That's not everything that was missing. Now we have all three sides, but we only have two of the angles. How do I find the third? It's just the complement of 25. So the complement of 25 is 65. So now I have solved the entire triangle. And when I ask you to solve for the triangle, it wants all the sides and all the angles. Okay, take a minute, and if you need to pause it so you can finish copying the notes, you may do so. And when the class is ready, press play. Okay, the next example. We have this triangle, XYZ, so of course we've labeled the sides, the lowercase letter of the vertice it's across from. They tell us that the measure of angle X is 32, and we've marked that on the picture, and the length of side X is 4. And we're asked to find the length of Z, to find side Z. So once again, let's think of what they gave us, this angle, this side. What do they want? This side. Okay, now let's see what we have. With respect to this angle, this side is the opposite, and this side is the adjacent. Which of these trig functions, sine, cosine, tangent, is a ratio of opposite to adjacent? That is tangent. Tangent of 32 degrees is equal to the opposite over the adjacent, which is Z. So this one has an extra step to solve because currently our variable's in the denominator. So to get it out of the denominator, we would multiply both sides by Z. So we have Z times tangent of 32 is equal to 4. And then to solve for Z, we would divide both sides by tangent of 34. So this would be the exact answer like you would see on a standardized test. And then the approximate answer, once again, got to make sure those calculators are in degree mode. When we punch in 4 divided by tangent of 32, you should get 6.4. Okay. If you need to hit pause to copy the notes, go ahead and do so, and then we have some U-tries. All right. Do hit pause now. Give everybody time to solve these. Help each other out. If you're not certain what to do or how to do it, please find somebody that does understand and get them to help you through 1, 2, and 3. And when the class is ready, go ahead and press play. All right, here they are worked out. Drew the picture, labeled the important information, looked at my triangle to see which trig function it was, set up the ratio, and solved. So go ahead and hit pause so that you can check all of these. We had one sine, one cosine, and one tangent. Okay. Now these are a little different. We have sides. We're missing angle measures. So what do we do when we're given sides, but we're missing angle measures? So in this first one, I want to find the measure of angle theta. How do I do that? Well, I look at what I'm given. With respect to angle theta, this is the opposite. This is the hypotenuse. All right, old SOHCAHTOA. Which trig ratio is a ratio of opposite and hypotenuse? Well, that is sine. So sine of theta is the ratio of the opposite side to the hypotenuse. Now, we're going backwards. And in math, when we think of going backwards, we think of undoing, which should inspire us to think of inverses. Like we studied inverse operations. The inverse of addition is subtraction. The inverse of multiplication is division. Now we're going to look at the inverse here. So to solve for this angle theta, we're going to have to use an inverse. But in this case, it's going to look like this. Because this is sine, we're going to use the inverse of sine, which you should see a little button on your calculator that looks like this. Sine to the -1. And we wouldn't read it as sine to the -1. We would say inverse sine. And if you're using the class set of calculators, the way you find inverse sine is you're going to use that sine button on the calculator, but you have to punch it twice to get this to show up. So you'd go sine, sine, and inverse sine will show up. So we do inverse sine of 3/7, and that angle measurement is approximately 25.38 degrees. So we're doing the same thing on number 2. We're finding an angle measure, so we're going to go backwards, so we're going to have to use an inverse of one of these 3 trig ratios. So once again, we look at this triangle with respect to angle x. 13 is the hypotenuse and 4 is the adjacent side. So this time I'm using cosine. So the equation that I would set up is cosine of x is equal to 4/13. And to solve for x, I have to do the inverse of cosine of 4/13. And this is approximately, let's punch it in. So we're going to hit it twice again. Punch, punch. 4 divided by 13, close parentheses, enter, and we should get to the nearest tenth. That would be 72.1 degrees. Okay, on the next page, we have one for you to try. Go ahead and pause the video until everybody's ready to look at this one. Okay, so this one, I'm asking you to find the measure of angle C. So it's with respect to this angle. With respect to this angle C, 6 is the opposite, 11 is the adjacent. So we'll do tangent of C is equal to opposite over adjacent. So we're solving for the angle measure. We use inverse tan, the inverse of tangent of 6/11. And so C is approximately, to the nearest degree, would be 29 degrees. Okay, your assignment is out of your workbook. It's page 211 all, and then page 215, 1 through 3, 7 through 9, and 13 through 18. If the video went a little too fast for you, you are welcome to watch it again. It is uploaded to YouTube. Also, this is out of lesson 10-2 in your textbook. So if you might find it more helpful to look at the examples in the textbook, if the video was a little too fast, that's what you can reference. And I will check this assignment on Monday. Thank you. You guys have a great weekend.